Alright, in our recent video we are able to look at how we can represent prime factors on what? On the Venn diagram, and this was one of our examples that we are able to do. Okay, so we are able to look at different numbers, and then in today's lesson we shall concentrate more on finding out how do these questions look like, and how do we really work upon these questions. For example, as you can see here, we have been given questions. Okay, we have been given questions. They are here in our activity. We are going to use the concept that we learned using how we can present our Venn diagram or our prime factor numbers on what? On a Venn diagram. So here we have been given what? A question, which is question 1, and they are saying our part A, represent the prime factors of 4 and 8 on a Venn diagram. Okay, so they want us to represent the prime factors of 4 and 8 on what? On a Venn diagram. Then our question B, they are saying find the lowest common multiple of 4 and 8 using the above what? The above diagram. That's the diagram that we are going to draw. And then they are also saying work out the greatest common factor of 4 and 8 using the above what? Using the above diagram. Alright, such a numbers, they need you to have the concept of representing prime factors on what? On a Venn diagram. First of all, we said for us to be able to attempt these questions, this is our question 1. Okay, this is our question what? Our question 1, let me write it 1A. Okay, so we are going to represent our prime factors, which is 4 and what? Which is 4 and 8. So here is going to be our solution. Here is going to be our what? Our solution. So when we are representing these prime factors on a Venn diagram, first of all, what we have to do is we have our numbers 4 and 8. These are the numbers that we have to represent on the Venn diagram. But what we have to first do is to ensure that we get the prime factors of these numbers of ours given, a 4 and a what? A 4 and 8. Okay, so assuming we use, we are going to use our factor tree method to first get the what? The prime factors of what? Of 4. So we said when you use our tree method, we draw this anchor. Okay, so in this anchor, now we look out for the number that can divide our 4, the least number which can divide our 4. We have a 2 here. So when we say 4 divided by 2, we shall get our answers 2. Okay, so we also still divide, look out for the number that can divide a 2 without a remainder. We have our 2 here. So what is 2 divided by 2? We get our 1. Okay, so we have got the prime factors of what? The prime factors of 4, where our 2 appears once and also appears twice. Okay, so we are also going to look at our prime factors of what? Prime factors of 8, where we are also going to use our number 2. What is 8 divided by 2? We get our answers 4. Our answers 4. Then also still divide our 4. Then we look for the number that can be divided by 4 and we get no remainder. We have a 2. Okay, so when you say our 4 divided by 2, we get our answers what? As a 2. So we also divide a 2. Which other number can we multiply by 2 and get no remainder? Can say 2 itself. So here we shall be able to get 1. So here our 2 appears once, second, then third. Okay, so now here we have been able to identify the prime factors of 4. So this simply means that we can now, using a set notation, okay, we are able to learn about how we can simplify this and putting them in a set notation in our recent videos. Please, if you didn't have a look at it, be able to go back and look at it for you to get the best concept. So when we represent this in our 4, the factors of 4 in our set notation, they are going to be equal to, our 4 is going to be having these values. We have our 2, 1, okay, we have our 2, 2. This is in a set what? Set notation or a subscript form. Okay. Then also, if you are to present our 8 here. Okay, let me write it here. Our 8. The set notation is going to be our 2 what? 2, 1. Our 2 also appears the second time. It also appears the what? The third time. Okay. So now here we can now be able to see our what? Our set notation is in 2, 2, 2, then 3, 2, 3. Okay. So now we shall now be able to now represent them on the Venn diagram. Remember, when we are to represent these prime factors on what? On our Venn diagram, that simply means we shall now be having a set. Okay, we shall now be having our what? Shall now draw our set. Shall draw our what? Shall draw our set. Okay, my diagram is beautiful. Also be able to draw a beautiful which is more than mine. So now here we can now say the prime factors of what? Prime factors of 4. And also here we come and indicate that the prime factors of what? Prime factors of 8. Okay. So now after putting these prime factors, now we have been able now to see the prime factors. We can now look at the prime factors which are common. We look at the prime factors of each that are what? That are common. Okay, let me get a different color here. We are going to look at the prime factors of these numbers. Remember, we have a 2, 1, then a 2, 2. Okay, then it ends here. Here we have also a 2, 1. Then we look for those that are common. I'm going to select this because it is common with here. Okay. Then I'm also going to select this because it is common in 8. Okay. So now we now find out, because we are going to represent this in our Venn diagram. Now, so this simply means here, those that are common, in using our basic concept of sets, we said that something that appears in common, we put it in the what? In the intersection. So this simply means we shall be having our 2, 1. Okay. Then we also have our 2, 2. Why are we putting them inside here? Because they are in what? They are in both sets. Okay, they are both prime factors of 8 and prime factors of 4. Okay, so now we shall now get the remainders. What is remaining in our prime factors of 4? Nothing. So we leave it that way. Then we also see what is remaining in our prime factor of 8. We have a 2, 3. So we shall just write our 2 what? Our 2, 3 here. Okay, so now here we shall have filled in the what? The Venn diagram. So now we come back now to the what? To the questions that are given. Represent the prime factors of 4, 8. Venn diagram here we have represented them. Then part B, they are saying find the LCM of 4 and 8 using the above Venn diagram. Okay, so now here they want us to find the LCM of what? Of 4 and 8. So for us to be able to get the LCM of 4 and 8, we said to get the LCM of 4 or prime factor 4 and 8, or prime factor 4 and 8. Okay, this is 8. The LCM here simply mean so this simply mean our f of 4, prime factor of 4 intersection our f of 4, this is going to be union, okay? Union f of 8, okay? So when we say f of 4 union, what? Okay, let me subdivide here. We are saying f of what? F of 4 union the prime factors of 8. So this simply means that we are going to get all the members of the prime factors of 4 and also the prime factors of what? The prime factors of 8. So here we can see these members are 2, 1, 2, 2, 2. Okay, put a comma. Then we have all these members. We also have a 3, a 2, 3. So these are the members, the union members. So now how do we get the LCM? Now our LCM is going to be equal to our 2 here, okay, which is this one. Then we multiply it by our 2. Then we also multiply it by our 2. So this simply means we shall be able to get our 4 times what? Times 2. Then our answer here is going to be equal to 8 as our what? As our LCM. Let me write this very well. Okay, let me write it well. Alright, so we are saying this is going to be what? Going to be 8. Then how do we get the greatest common factor? For us to be able to get the greatest common factor is the same as f of 4, the prime factors of 4 intersection, the prime factors of what? Prime factors of 8. So this is going to be equal to what are those that are intersection? We said there are 2 that, okay? So here we shall now be able to say our 2 times 2. Then our answer shall be equal to what? Shall be equal to 4. So here we shall have solved the what? Solved our number. What to bear in mind is to first find the prime factors of what? The prime factors of 4, and also find the prime factors of 8. Then you look out for those that are common. We have a 2 what? You list them. We have a 2, 1 here, then 2 here, then also we have it here. So that simply means that when we are now drawing our Venn diagram, we look for those prime factors that are what? That are common, okay? Then after looking for those that are common, you look at what is remaining in our prime factor 4, you come and write them here. But here we are remaining with 0. That's why our remainder here was 0. So also here when you look at this, we had a remainder of 2, 3. So that's why we are able to bring our 2, 3 here. So after identifying them now like that, then you go ahead and find the LCM. Some more question. LCM means the prime factors of 4 intersection union the prime factors of 8. So you list them. After listing them, then you multiply them. You'll be able to get the right answer. Okay. Then also to get the intersection, you just come and pick out our 2 here, then our 2 1, then our 2 2, then you multiply them. You'll have solved the number very well. That's how we can be able to solve the numbers on a Venn diagram and the related related questions that are required to be solved. So we shall also be looking at some more questions of this kind, such that we can be able now to learn more of the tricks that they always ask. So for this, I do say thank you very much. Please be able to check out on our playlist below for the recent lessons that you might have missed, okay? Because one lesson builds on one another. Also be able to subscribe to get some upcoming lessons. As soon as we put a lesson, you can be able to get a notification, and we run or we study at the same time. Okay. Also be able to comment for us to know your view about what we are teaching, about what we are learning. Okay, God bless you. Nice moment. See you in the next lesson.